How are you, my friends? In this video, I'm presenting 6 old exams questions related to Gaussian and Gauss-Jordan elimination methods from pre-calculus course lectures 31 and 32. Solve the linear system by Gauss-Jordan elimination method. This is 2 by 2. Clearly here, we have to rearrange the system first. So we see the LCD here is 3, so I can multiply the whole equation by 3. Second one, I can multiply the whole equation by 10. Remember here, this is x and y, this is y and x. We have to rearrange also that one. So when you multiply by 3, you get x minus 1 plus 3y is equal to 3. Multiply by 10, you get minus 5y. 10 divided by 5 is 2, so 4x is equal to 50. Let's rearrange here, x plus 3y is equal to 4. 4x at the beginning minus 5y is equal to 50. Equation 1, equation 2. So we write the augmented matrix. So this is the system now, 2 equations. So it will be 1, 3, 4. 4 minus 5, 50. This is already 1. So I have to make this 1 here 0. So I multiply by minus 4. All row 1 add to row 2. Remember, minus 4 times 1, minus 4 add to 4, 0. Minus 4 times 3 is minus 12. With the minus 5 there, it will be minus 17. Minus 4 times 4 is minus 16. You add to 50, it will be 34. Now I have to make this number here, the minus 17, I have to change it to 1. So I can divide row 2 by minus 17 or multiply 1 over minus 17 or minus 1 over 17. It's up to you. So we'll get 0, 1, minus 2. Now I have to change this number 3 to 0. So I take row 2, multiply by the opposite, which is minus 3. You add to row 1. So this is already 1. You multiply here by the minus 3, you add, you get 0. Minus 3 times minus 2 is 6. You add to 4 is 10. So now easily I can say x will be 10, y will be minus 2, and that will be the solution of the system. Now this is the same idea, 3 by 3, it is already arranged. So I will write now the augmented matrix of this system 3 by 3. So this is the given here. Directly we can write the augmented matrix 3 to 1, minus 4, minus 3, minus 2, minus 1, 1, 3, and then 1, 1, 2. I need the first number here on the top here should be 1. So I can interchange row 1, row 3. So 1 minus 2, 3, 2. It will be in row 1. I take row 3, 1 here, row 1, 3 minus 4 minus 1, 1. I put it there in row 3, 3 minus 4 minus 1, 1. Now I have to change, as I have seen in the lecture, 1, use it to change this 2 to 0. Use this 1 to change this 3 to 0. So I can multiply row 1 by minus 2, all of row 1. So it will be there 0. Minus 2 times minus 2 is 4. With the minus 3 becomes 1. Minus 2 with the 3 will be minus 6. Plus 1 will be minus 5. Minus 2 and 2 will be minus 4. With the 1 is minus 3. The same I can do for minus 3 multiplied by row 1. Add to row 3. We will get 0, 2, minus 10, minus 5. Now I can continue. This number is 1 here. So I have to change the number under that to 0. So I multiply by the opposite minus 2. So multiply by minus 2 here. You will get 0. Multiply by minus 2, you get 10 plus 10, 0. Multiply by minus 2, you will get 6. And there is minus 5, so that will be 1. So 0, 0, 0, 0x plus 0y plus 0z is equal to 1. That's impossible. So the system is inconsistent, and there is no solution for this 3 by 3. Now, this one, we have 3 by 3, x plus y is equal to 5, y plus z is equal to 4, x plus 2k, z is equal to 1. This system is dependent, and it has infinitely many solutions. Let's find k. First, we have to rearrange as usual. So x plus y, there is no z there. Here, there is no x, so I can leave space here. Y plus z is equal to 4. There is x, there is no y here, so this will be in the middle 0, 2kz is equal to 1. So let's write the augmented. So it will be 1, 0, 1, 1, 1, 0, 0, 1, 2k. And here on the right side, we say 5, 4, and 1. This one is 0, 1. This one is 0. This one we have to make it 0. So I multiply row 1 by minus 1, and then I will add to row 3. So it becomes here, see, minus 1 times this one is 0. Minus 1, you add to 0, this is minus 1. This is, you multiply by 0, you still get 2k. Multiply with minus 1, you get minus 5. With this one, you get minus 4. Now this is already 1. Under that, it should be 0. So I changed the minus 1 in the third row to 0 here. See this minus 1 here. So I multiply by 1, which is nothing. Multiply by 1 on row 2, add. So directly we can add there. We can add here, we can add. So I get 0, 0, 2k plus 1, 0. So what will make the whole row 0 to have infinitely many solutions? This one is already 0, this one is already 0, the last one is already 0, so we have to take 2k plus 1 is equal to 0, so k will be minus half. Question number 4, if this is the augmented matrix of a linear system, let's find the solution. So this is 2, 3, 5, 3, 4, 6, 13 minus 9. Let's see, this is already in the augmented. So let's change this number here, the 4, into 0. So what will happen here? I will leave now row 1. There is no need to change this number to 1 because we will have fractions and a big mess. So we can leave it because we have to work in the last row first. Let's multiply with minus 2 here and then add. So it will be minus 4, add will be 0, but we have to change the whole row, remember. So minus 2 times 3 will be minus 6, you add, you get 0. Minus 2 times 5 is minus 10. When you add to 13, that will be 3. Minus 2 times 3 is minus 6, and minus 9 is minus 15. So I have 0, 0, 3 minus 15. Now I can take 3z here is equal to minus 15, or I can say divide by 3. So z is directly minus 5. So we can see from the last slide, this augmented matrix, z already was found minus 5, and we are left with two variables, x and y, with one equation here, row 1. So I have to let either x or y is equal to t. So I will take let y is equal to t. T is any real number. And then I write row 1, which is 2x plus 3y plus 5z is equal to 3. So I replace y here by t, and the value of the z is minus 5. Now let's rearrange this equation. 2x is equal 3t, take it on the other side, becomes minus 3t, and minus 25, take it on the other side, add to 3 becomes 28. So x will be 28 minus 3t divided by 2. So this is the value of the x in terms of t. This is the value of the y in terms of t. And this is z, where t is any real number. So this is the general solution for the infinitely many solutions. Now, Find the value of m here if this is augmented matrix of a linear system where there is no solution, which means inconsistent. So what can we do? We have already 1, 0, 0, and already we have 1. So I have to change this number now to be 0. So what can I do? Minus 2 times row 2 plus row 3 will make this number 0. So now it will be, let's see, minus 2 times 1. I will do it for you. That's 0 and you add to 2. Minus 2 times m squared, you add to 8. So it will be 8 minus 2m squared. Minus 2 times the 1 is minus 2. When you add, you get here m minus 2. So be careful about these numbers. So this is 0, 0. When we have inconsistent, we should have 0, 0, 0, and then there is a number here. So I put here 8 minus 2m squared is equal to 0. Take 2 is a common factor. Then we factor inside 2 minus m, 2 plus m. So to make this one 0, m will be either 2 or minus 2. Now, if I put this one is equal to 0 here, m minus 2 is equal to 0, m will be 2. So if m is equal to 2, it will be 0, 0, 0, 0. So if I put 2 here, then the last row becomes all zeros, which is dependent. Then if m is minus 2, you put here minus 2 there, you get minus 4. So it will be 0, 0, 0, minus 4. This is inconsistent. So now here you check the values of m that will make for sure all zeros except the last number here. So it will be 0x plus 0y plus 0z is equal to number. It can be positive or negative or fraction, but not 0. So this is inconsistent. So the only value we can take for m is minus 2. Now let's see question number 6. We have already arranged linear system 2 by 2. There's 2 equations in 2 variables. We have to write the augmented matrix as this given here. So let's start from the beginning. Here we have a lot of calculations in radicals. So we write the augmented 2 square root of 2. Just be careful there. 3 square root of 5, 7. 3 square root of 2 minus square root of 5 minus 17. Just deal with these as numbers, but they are little ugly numbers. So we have to make this number here 1. So I can divide by 2 square root of 2. So divide this, becomes 1 here. 3 square root of 5 over 2 square root of 2. 7 over 2 square root of 2. Now what else? We have to make this number 0. So I have to multiply row 1 by 3 minus 3, the opposite of this, minus 3 square root of 2 times row 1 plus row 2. So this will be easy, 0. Now here, minus 3 square root of 2, I multiply with this. So I wrote it here for you. Minus 3 square root of 2 times 3 square root of 5 over 2 square root of 2. We cancel the square root of 2 here. So we get minus 9 square root of 5 over 2. And then we have to add that with minus square root of 5. So when you multiply this by this, you will add minus square root of 5. So multiply up and down here by 2. So you get minus 11 square root of 5 over 2. We write it here. It's not an easy calculation. Minus 3 square root of 2, we multiply by this. So I get minus 3 square root of 2 multiply by 7 over this. You cancel square root of 2. So minus 21 over 2. We have to add with minus 17. So multiply up and down by 2. Minus 34. Minus 21 is minus 55 divided by 2. So to make this number 1, you have to multiply by the reciprocal, which is 2 over minus 11 square root of 5. We can do that. Here multiply by this. So you get all 1 here. And then multiply minus 55 over 2 by 2 over minus 11 square root of 5. You cancel the 11, you cancel the minus, you get 5, you cancel the 2 also, 5 over square root of 2, which is square root of 5. So I write it here. Now, this number here, 3 square root of 5 divided by 2 square root of 2, I can multiply by the conjugate here. Square root of 2 over square root of 2, this will be 3 square root of 10 divided by 4. Also, 7 over 2 square root of 2, I can multiply by the conjugate. So it will be 7 square root of 2 divided by 4. So this is what we have in the given. See, look at the given here, 1, 0, 1. We have 1, 0, 1. 3 square root of 10 over 4. So this is E, this is F. So E is 7 square root of 2 divided by 4. F is square root of 5. Let's find 4EF. So 4 multiplied by E multiplied by F will be 7 square root of 10 is the answer. Now here are the answers of these 6 questions. For other examples, please see the videos on pre-calculus course lectures 31 and 32, Gaussian and Gauss-Jordan elimination methods. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.